This video is about multiplying and simplifying radicals. So before we get to multiplying, let's review what happens when we have a variable under our radical. So remember, we want to look at the exponent. If it is even, we just cut it in half and move the variable with half of the exponent outside of the radical. If it's odd, we keep one variable underneath and then we cut the remainder in half and move that outside. So in number 1, the square root of m to the 10th and x to the 8th, they are both even exponents. So we're going to have m, half of 10 is 5, so m to the 5th. And then we're going to have x, half of 8 is 4. Because they were even exponents, both things move outside of the radical. In number 2, we also have a number underneath. So we have the square root of 4x to the 4th, y to the 9th. So we're going to look at each term individually. So 4 is a perfect square, so we know the square root of 4 is 2. There's nothing left under the radical. X to the 4th is an even exponent, so we're just going to cut that in half and we get x squared. Now y is an odd, so we're going to keep one y underneath, which changes this exponent to 8. And we cut 8 in half, we get y to the 4th out front. Our last review problem then is number 3, root 20 x y to the 3rd z to the 12th. So first we're going to break down 20. So two numbers that multiply to 20 are 5 and 4. Two numbers that multiply to 4 are 2 and 2. So we have a pair of 2's, and we have a 5 under the radical. Now, x just has an exponent of 1, so that stays under the radical, and there's nothing to divide, because if I took away 1, I'd be at 0. Y is an odd exponent, so we keep 1 underneath. That changes to an exponent of 2. Half of 2 is just y to the 1st, which we can write as y. And then z to the 12th, that's an even number, so when we cut that in half, we get z to the 6th. So in order to multiply radicals, remember that you need to multiply the inside by the inside and the outside by the outside. So in number 1, the inside numbers that we have are 5 and 5. The outside numbers that we have are 5 and 1. So when we go to multiply this, we have 5 times 1 root 5 times 5, which gets us 5 root 25. Now, 25 is a perfect square, so the square root of 25 is 5. So we have 5 times 5, which gets us 25. In number 2, we have 1/3 root 9 times 24 root 9. So on the inside, we're going to multiply 9 times 9, and on the outside, we're going to multiply 1/3 and 24. So we have 1/3 times 24 root 9 times 9. 1/3 of 24 is 8, so we have 8 root 81. Now 81 is also a perfect square because the same number times itself gets us 81, and that number is 9. So we have 8 times 9, which is 72. In number 3, on the inside, we have 11 times 3, and on the outside, we have -7 times -3. So we have -7 times -3, root 11 times 3, which gets us 21 root 33. 33 is not a perfect square, and if I go to simplify this, this simplifies to 3 and 11. It has no pairs, so it's already simplified at 21 root 33. In number 4, we have 1/2 square root of 6 times 8 square root of 5. So we're going to multiply the inside numbers of 5 and 6 and the outside numbers of 1/2 and 8. So when we multiply, we get 1/2 times 8 root 6 times 5, which gets us 4 root 30. Again, if I go to break down 30, I can break into 3 and 10, 5 and 2. There are no pairs there, so 4 root 30 is as simplified as we can get. In number 5, we are multiplying on the inside 12 and 6, and on the outside -3 and 5. So we have -3 times 5 root 12 times 6, so we get -15 root 72. Now, you can pick any numbers to multiply to root 72. I'm just going to go back to the numbers I just used. So 12 and 6. 12 breaks down to 2 and 6. Now, usually we want to break down to our prime factors number, but if we already have a pair of numbers, let's make our life easier and just use those. So we would have 15 Negative 15 times the pair of 6, root 2, which gets us negative 90 root 2. In number 6, when we multiply, the inside numbers are 15 and 12. The outside numbers are 1/2 and 5/3. So when we multiply, we have 1/2 times 5/3 root 15 times 12. So when you are multiplying fractions, the top multiplies together and the bottom multiplies together. So 1 times 5 is 5, and 2 times 3 is 6. And then we have 15 times 12, which gets us 180. So we can break down the square root of 180 into 18 and 10. 10 breaks to 2 and 5. 18 breaks to 9 and 2. 9 breaks to 3 and 3. So we have a pair of 3's and a pair of 2's. So we have 5 root 6 times 2 times 3. Root 5 is left over. Everything else has a branch from it. So when we multiply here, we get 5 root 5. Find the area of a square. So in a square has 4 sides that are all equal to each other. So we know that the base and the height have to be the same in a square. So when we multiply, then we're multiplying base times height. So 5 root 6 times 5 root 6. The numbers on the outside are 5 and 5. And the numbers on the inside are 6 and 6. So when we multiply together, we get 25 root 36. 36 is a perfect square, so the square root of 36 is 6. So we have 25 times 6. And 25 times 6 gets us 150. When we're finding the area of a rectangle, we're doing the same thing, base times height, but we're going to have 2 different sides now. So we're going to multiply 7 root 6 times 2 root 3. On the inside, we're multiplying 6 and 3. And on the outside, we are multiplying 7 times 2. So when we multiply, we get 14 root 18. We can break 18 down into 9 and 2, 3 and 3. So our pair of 3's is going to multiply with 14. And we have a 2 left over. So that simplifies to 42 root 2. Now let's look at multiplying where there's variables under the root. Remember when we were multiplying exponents before, say we had something like x to the 4th times x to the 6th. What we would do then is we would add those exponents together. So we're going to do the same thing here. So we're still multiplying. So in number 4, we're going to multiply those numbers together. 20 times 4 is 80. And then we're going to add the exponents. So we have x to the 2 plus 3, which is 5. And y to the 1 plus 10, which is 11. Now we can simplify this. So 80 is going to simplify to 5 and 16. 16 simplifies to 4 and 4. So we have our pair of 4's, and we have our 5 under the radical. Then we look at our variables. So because x is an odd number, one of them is going to stay underneath, which changes that to an exponent of 4. So we have x to the 4th, half of 4 is 2. Y is an odd number at 11, so one of them stays under. That goes to 10, and half of 10 gets us y to the 5th out front. In number 5, we only have variables, so we're just going to add our exponents. We have m to the 3 plus 5, which gets us m to the 8th, and then we have y to the 10 plus 11, which is 21. Now we're going to simplify. M is an even exponent of 8, so that splits in half to 4, so we have m to the 4th, nothing under the radical. Y to the 21st, we need to leave one y under the radical, which changes that to 20, and then half of 20 gets us y to the 10th out front. In number 6, when we multiply, we have 2 times 16, which is 32, x to the 1 plus 1, which is 2, and then y to the 3 plus 2, which is 5. Now, 32 can break down to 8 and 4. 8 can break down to 2 and 4. So we have a pair of 4's. We have a 2 left over. X is an even exponent of 2, so half of 2 is just x to the 1st. So we'll just write that as x. y is an odd number, so 1 stays under, change our exponent to 4, and then half of 4 gets us y squared. Now let's look at what happens when we multiply a root by itself. So when I multiply a root by itself, root 2 times root 2, both of them are under the square root, which gets me the square root of 4, and we know the square root of 4 is 2. So notice that the radical really is just canceling each other out, and we're left with a number under it. Same thing with root 3 times root 3. We get the square root of 9, which is just 3. Number 3, square root of 8 times square root of 8 gets us square root of 64, which is just 8. So each time the radical is canceling out. So root 10 times root 10 is the square root of 100, which is just 10. So when we have variables here, xy times xy, if we add those exponents, that gets us x squared y squared. When we take the square root, they're both even exponents, so we cut them in half, and it gets us back to xy. So it's leaving us what's under the radical. Number 6, we have the square root of a to the 4th and b to the 2nd. When we divide those by 2, because they're even exponents, we're left with our original a squared and b. So what happens when we multiply a square root by itself? When you multiply a square root by the identical square root, the root cancels out, and we're left with just the number. So when we are simplifying square roots with exponents, whatever's in the parenthesis, because it's squared, we're going to rewrite that twice. So in this case, we would have 2 root 6 times 2 root 6. Then we're going to multiply the outsides and the insides together. So the outsides, 2 times 2 is 4. The inside, 6 times 6 is 36. Now, 36 is a perfect square, so we have 4 times 6, which is 24. In number 2, both things are also in parentheses. So we have negative 2 root 6 times negative 2 root 6. Negative 2 times negative 2 is 4. 6 times 6 gets us 36. Again, 36 is a perfect square. So we have 4 times 6, which is 24. Now, in number 3, 2 is not in the exponent. So in the parentheses. So that doesn't get the exponent. So 2 only gets written once, and then we have root 6 times root 6. So we only have one number outside of 2. Inside we have 6 times 6, which is 36. So that gets us 2 times 6, which is 12. Number 4, negative 2 is outside of the parentheses. So we have negative 2 times root 6 times root 6. There's only one number outside, negative 2. In the square root, 6 times 6 is 36. The square root of 36 is 6. So we have negative 2 times 6, which is negative 12. In number 5, we have 4 root 10 squared. Both things are in parentheses, so we're going to do 4 root 10 times 4 root 10. 4 times 4 is 16. 10 times 10 is 100 under the square root. We know that 100 is a perfect square, so we get 16 times 10, which is 160. In number 6, we have negative 4 root 10 squared. So we're going to have negative 4 root 10 times negative 4 root 10. So anything that's in parentheses gets rewritten twice. Negative 4 times negative 4 is 16. 10 times 10 is 100 under the square root. Again, 10 is a perfect square, or 100 is a perfect square and gets us 10. So 16 times 10, 160. Now the last few have a variable in them. So in number 7, we have 9 times the square root of a times the square root of a. So we have 9 square root of a squared because there are 2 a's. When we take the square root of a squared, we get 9a. In number 8, we have negative 9 times root a times root a. So we have negative 9 root a squared. Root a squared, when we split that in half, just gets us a, so we have negative 9a. And our last one, then, we have negative a root b times negative a root b. Negative a times negative a gets us a squared. Under the square root, we have b squared. When we take the square root of b squared, though, half of that is just 1, so we'd have a squared b.